This game will prompt the user to enter a word that can be made from the 8-letter prompt word. For example, here our word is shocking, so we could have sing or king or similar kinds of word around it. We're going to make this happen using UIAlertController, because it's a nice fit for this problem and also gives me the chance to introduce some new teaching. I'm all about ulterior motives, me. So back in Xcode, in view.load, up here underneath super, I'm going to say navigation item dot right bar button item equals a UI bar button item. This time with system item dot add. Then for the target, we will say self, and the selector will do hash selector prompt for answer. Now again, this method does not exist yet, so we get an error here. That's normal, don't worry about it. So we're getting a new right bar button item with an add symbol, which is usually a plus mark and things, and linking it to our prompt for answer method we'll write shortly. And this is how users are going to enter their words. They'll say, look at the word, think about it carefully, press plus, we'll show an alert controller, they'll type into the box and press submit from there. Now before I give you the code, let me explain what you need to know. You see, we're about to use our own closure for the first time, and things get a little bit complicated, as you'll see. As a reminder, closures are chunks of code that can be treated like a variable. We can send the closure somewhere where it gets stored away and executed later. To make this work, Swift takes a copy of the code and captures any data it references so it can use them later. But there's a problem. What if the closure references the view controller? Then what could happen is a strong reference cycle or a chain cycle. The view controller owns an object that owns the closure, that owns the view controller, and so on, and nothing will ever be destroyed. Strong reference cycles used to be hard to find, but you'll be glad to know Swift makes them trivial. In fact, Swift makes it so easy, you'll find yourself using its solution even if you're not really sure there's a chain cycle, simply because you might as well. So, please brace yourself. You've learned from prior experience that closures are hard, and we're about to look at our first actual closures. The syntax will hurt, but hopefully it'll all make sense soon enough. If you're ready, let's start coding. I will scroll down to make some space below our table view methods and write at obj_func prompt for answer. Let AC equals a new UI alert controller, with the title being enter answer, message nil, preferred style dot alert. Then call a new method ac.add text field. Delete this closure, it can be nil by default. Then let submit action equals a new UI alert action with the title submit, the style default, and for the handler, previously we've used a method name here, or even deleted it entirely to have the default just dismiss the alert controller. Now though, we're going to have a custom closure in here, and we're going to use trailing closure syntax. So I'll scrap all this work here, all the handler stuff, end the parens, open a brace, and say weak self, comma, weak AC, then action in. Guard let answer equals AC question mark dot text fields question mark 0 dot text else return. And then finally self question mark dot submit answer. After that we'll say ac.add action, submit action, and present AC animated true. This code won't build yet because there is no submit method yet, and that's fine. We'll fix these things soon. But first, I want to talk about what all this code does. There's stacks of complicated things in here. I really want to break it down to small chunks for you. As a reminder, this prompt for answer method is being called by our bar button item up here using the target action system of UIKit. And that requires us to use the @Object-C attribute before our method name to expose this thing to Objective-C. Then we make a new alert controller. That's old news. Line 51, we add a text field to the alert controller, which is where the user will type their text into to answer the anagrams as they go. We could do more of this thing, as you saw as a configuration handler, but here though, just scrap it and empty text field's fine. This adds an action to the alert controller, as you've seen previously, and we present it onto the screen, just like we did in Project 2. That leaves the tricky stuff. These lines here, creating the submit action. These handful of lines demonstrate a number of important Swift features back to back. First, we have text fields. We added this thing on Live1 here. We have ac.addTextField. This adds a new text box to the alert controller. So down here, we can try and read it out. It's index 0. It's the first text field in our alert controller. Text fields are backed by a UIKit class called UITextField. It's just editable text that shows a keyboard when tapped. It's nice and easy to use. Like I said, while typing, we have trailing closure syntax here, ending it here. So rather than passing a method name or a function into the handler, we're using trailing closure syntax nicely to make it look really good. Next up is this line of code here. This specifies the input into the closure. And it's really important here because we have to make sure we use weak self and weak AC, because both the alert controller and the view controller are referenced inside our closure. We want to make sure this closure does not capture these strongly. It must be used weakly, which is where we get these question marks from. It's a weak reference now. It might not exist in the future, could be nil in the future. So that will safely check the alert controller is still there before running the closure, and safely check self is still there before calling submit. This avoids the strong reference cycle, that retain cycle that holds onto memory for a long time. Now you'll see there's actually all sorts of optionality here. The AC, the alert controller, might not exist. The text fields array might not exist. And in fact, might have no text either. If you look at this text thing, that's also optional. So there are 3 levels of optionality here, and Swift flattens them all down to a single variable answer. If that has anything inside it, the method will run. Otherwise, it will exit immediately with its return keyword right here. Now, one of the lovely things about Swift is it's very, very hard to get retain cycles by accident. If I had removed self question mark from here and to use submit, I'm saying try to call submit on a strong version of self, and it'd be very unhappy with that. It would complain bitterly. It'd make you add self dot to make sure you absolutely mean to capture self. So in summary, we have lots of things going on here. We have the trailing closure syntax happening with the open braces and close braces here. We have code with self question mark thanks to our capture list, this weak self action in and similar. We have a massive optional unwrap going in here to make sure it's all safe. And finally we call submit. Now I should say, this closure does not actually use the action itself. That UI alert action here is not used. Previously we read the action title to load the right web page. And now, actually, this alert action isn't used. So having it here isn't required anymore. We could just use underscore in to say, I don't really care what value's passed in. What matters, though, is this keyword here, in. This divides our closure into 2. Before the in describes the parameters coming into the closure. We're weakly capturing self, weakly capturing the alert controller, and we don't care about the alert action that's coming in, but it'll still come in. And after the in, we have the body of our closure itself, the things we want to do when that code is run. Now, all this is complicated, and I'm not going to pretend otherwise, but we're going to be coming back to this repeatedly in the future. You'll have lots of chance to understand it better. Before we move on to the next step, let's just make your code compile again. Down here, I'm going to say func submit underscore an answer of a type string. Inside there is where we'll write our next code. And that will hopefully make our code compile cleanly because now submit exists.